Renewable energy is a crucial element of power system decarbonization. Current renewable energy policies incentivize investors to build power plants in the places with the best resources, for example, higher wind speeds. But when wind is not blowing, other generation or storage technologies have to enter the scene. However, there exists complementarity of renewable energy sources, which, if captured, can substantially reduce the need for flexible generation and backup capacity. For Europe, only wind resource complementarity can save estimated 4 billion euros of unnecessary costs annually by 2050. But how to incentivize investors to build power plants in those complementary locations? Could a support that takes system reliability needs into account make the difference? To understand that, a model should be created to design such an incentive scheme and simulate its effects. The model consists of 3 key layers. The operational power system model is in charge of power generation profiles for each hour of each power plant and available resources, so it's able to capture complementarity of renewables and their fit to the existing electricity generation and demand profiles. Based on this information, the value of different renewable energy power projects for the system can be calculated and the proper incentive created. The amount of support defines which projects will be profitable and consequently get built. The overall technology mix then gets updated and the cycle repeats. Let's consider a simplified hypothetical example. Imagine a region with high potential of solar energy resources but mediocre wind. There is already base load available and some new power plants need to be built to meet the future demand. Under the classical support, wind is not profitable and only solar PV power is introduced. Evening and morning electricity consumption peaks will need to be covered with fossil fuel-based generation. Let's see what happens if a system reliability-based support for renewables is taken into action instead. After initial amount of solar PV built, its value for system drops, and the support starts to favor wind instead and makes it more profitable. The resulting power system requires less fossil fuel capacity, it's overall cheaper and more environmentally friendly. For the future, there is lots to be done to turn this simple calculation into a real model and this hypothetical example into real-world applications. And we are welcoming collaborations to make it come true. See more details in our paper titled "Steering Renewable Energy Investments in Favor of Energy System Reliability – A Call for a Hybrid Model."